Welcome to EDU World Space.
Alright, so here's the problem 90 in chapter 19. Consider a system that consists of two standard plane dice with the state of system defined by the sum of the values shown on the top face. So the two arrangement of top faces shown here can be viewed as two microstates of the system and explain why. So first, we want to know what are the microstates. So microstates represent the possible arrangement for the system. So for each die, there are 6 possibilities for the top faces. So if there are 2 dies in the system, that is 6 times 6 will result into a 36 possible arrangement, or you can say 36 microstates. Part B, to which state does each microstate correspond? So the left pair has 1 plus 2, that is state of 3, and the right side has 4 plus 3, that is 7. So on the left side, the dice belong to state 3, state 3, and the right side belongs to state 7. Part C, how many possible states are there for the system? So the total number of possible states goes from 1 plus 1. The minimum is 1 plus 1, and the maximum is 6 plus 6. So 1 plus 1 is 2, 6 plus 6 is 12. So from 2 goes to 12, there are 11 possible states. So part D is asking you which state or states have the highest entropy. So for this, we want to say that the state with the most microstates will have the highest entropy, because number of microstates, the larger the number of microstates, the higher the entropy. So state 7 will have the highest entropy. That is because state 7 can have 6 different microstates. That is 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. So there are 1, 2, 3, 4, 5, 6 different possibilities. So 6 microstates. And if we look at the state of 6, so state 6, the only possibilities are 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. So there are 1, 2, 3, 4, 5 microstates. And state 8 will be 2 plus 6, 3 plus 5, 4 plus 4, 5 plus 3, and 6 plus 2. So this is also 5 microstates. So as the number goes further from 7, the number of microstates will decrease. So as a result, the state of the highest entropy will be state 7. Now part E, which state or states have the lowest entropy? So the lowest entropy will have the fewest microstates. And that will be the state of 2 and the state of 12. State of 2 only have the combination of 1 plus 1, and state of 12 only have combination of 6 plus 6. And both of these two states only have 1 micro states. All right, so the last one is calculate the absolute entropy of the two-die system. So the absolute entropy is equal to S equal to K times ln W. And in this equation, K is the Boltzmann constant that is equal to 1.38 times 10 to the minus 23 joules per Kelvin. And W is the total number of microstates. So from the part A, we know that the total microstates is 6 times 6. So the absolute entropy will be equal to 1.38 times 10 to the minus 23 joules per Kelvin times ln of 36. And that will be equal to 4.9 times 10 to the minus 23 joules per Kelvin.